welcome back to another explainer. Today we're doing a real masterclass in heavy machinery. We're going to meticulously tear down and then resurrect a massive piece of industrial equipment, the PPI VWS 650 water ring vacuum pump. We're going step by step through the dismantling and installation procedure. And honestly, the absolute lifeblood of this entire process, it's understanding the critical importance of part fitting clearances. So let's just get right to work.
Okay, let's dive into this. When you look at one of these massive steel pumps, what do you think is the single most critical factor in rebuilding it successfully? You might think it's raw torque, heavy lifting, or just brute force. But actually, success completely comes down to micro measurements. We are talking about internal fitting clearances that are so incredibly precise that a single slip-up, literally being a millimeter off, will completely ruin the efficiency of the machine, or worse, destroy it the second you turn it on.
So here's our roadmap for today. First, safety first and prerequisites. Then, dismantling the beast. After that, we hit the climax, internal clearances. Next is the precision assembling procedure, and finally, post-assembly checks and commissioning.
All right, moving right into part one, safety first and our prerequisites. Look, you're operating around industrial-grade electrical power and highly pressurized lines here. Before you touch a wrench, you must set the stage. First, lock out and tag out that electrical supply to the main motor and physically pull the motor fuses. A zero-energy state is the absolute goal here. Next, isolate the machine by closing the suction, discharge, and seal water line valves. And finally, pull the drain plugs at the bottom of the casing covers to empty out any remaining service liquid. Having a safe, completely dry workspace is 100% mandatory before we go any further.
Now, what's really interesting about this next prep step is that it's actually your blueprint for survival later on. It's called match marking. Before taking anything apart, you take a center punch or some paint and mark the exact orientation of all the major joints. We're talking bearing brackets, to the casing covers, center body, right down to the control discs. Why? Well, if you don't ensure an identical orientation during reassembly, the internal ports simply won't align, and the pump will not work. It's that simple.
Which brings us to part two, dismantling the beast.
The PPI VWS 650 uses a two-stage rotor arrangement, and breaking it down safely requires a fastidious step-by-step sequence. It's kind of like an industrial excavation. Step 1, pull the coupling or pulley from the shaft using a heavy-duty puller. Step 2, remove the outer covers, the lock nuts, and carefully extract the bearings and brackets from both ends. Step 3, slide back the glands and extract those packing rings with a specialized hook. Step 4, unbolt the casing covers and gently pry them loose using jacking screws to expose your control discs. And finally, Step 5, pull the central shaft, sliding that first stage rotor, the separating wall, and the second stage rotor right out of the main casing body.
But actually, let me pause you right at step 4 of that sequence. When you pull those control discs, which are also known as port plates, do not scratch their finely machined faces. I literally cannot emphasize this enough. This isn't about just keeping the parts looking pretty. The clearances here are so phenomenally tight that a single scratch or even a slight score mark from a careless tool will create internal leakages that completely destroy your vacuum efficiency. Treat these components like fragile glass.
All right, moving on to section 3, which is really the climax of this whole operation, internal clearances.
If you take away just one thing from this entire explainer, let it be this. The thickness of the casing body gaskets directly dictates the internal axial clearances of this PPI pump. It's an incredibly delicate balancing act, and this brilliantly illustrates the extremes. If you use a gasket that is too thick, you're going to get massive internal leakage and a total loss of vacuum. But if the gasket is too thin, no way around it, the rotor literally binds or seizes against the control discs the second you start it up. You absolutely must use identical, genuine manufacturer-specified gaskets here. The physics simply demand unforgiving precision.
Let's transition to section 4, precision assembling procedure. The rebuild is essentially the reverse sequence, but it requires incredibly careful handling. Think of it less like heavy construction and a lot more like industrial watchmaking. Step 1, fit the rotors onto the shaft with the correct orientation and guide them into the central casing, applying your perfectly measured gaskets with just a light sealant. Step 2, align your control discs with those exact match marks we made earlier, fit the casing covers and, this is absolutely vital, cross-tighten the bolts evenly in incremental stages. Uneven wrenching creates uneven internal pressure and that throws off your clearances. Step 3 involves installing the stuffing box seals, and Step 4 is refitting the bearing brackets and bearings.
Let's look a little bit closer at that stuffing box installation, because this trips people up.
When you install your new gland packing rings, you must intentionally stagger the joints at 90-degree or 120-degree offsets. Why do we do that? Well, if those joints line up, you've essentially just built a straight, unobstructed highway for water and vacuum to leak right out of the casing. Also, make sure the lantern ring, which is the component that actually distributes the cooling fluid, perfectly aligns with the seal water flushing hole. And finally, snug those gland nuts finger-tight only. Seriously, do not crank them down with a wrench yet. Those final adjustments have to be made dynamically while the pump is actually running.
80 to 90 degrees Celsius. When it's time to reinstall your bearings onto the shaft, please put the hammers away. This isn't a blacksmith's forge. You heat the bearings in an induction heater or an oil bath to exactly this temperature range. The metal expands just enough so that the bearings slide smoothly onto the shaft, like a hot knife through butter. It'll seat perfectly flush against the shoulder without needing any brute force at all.
Once they're seated and locked in with their washers and nuts, you'll pack the bearings with the recommended lithium-based grease. But here is the real catch. Fill the cavity space strictly to 1/3 or 1/2 capacity. Overpacking a bearing is a super common rookie mistake. Doing that causes churning inside the housing, which generates a massive amount of heat, and that will prematurely destroy the bearing you just spent all that time so carefully installing.
Next up, reinstall the C-shaped distance shims exactly as they were removed. Remember that match marking and careful grouping we talked about right at the beginning? Yeah, this is exactly where it pays off. These specific shims physically center the rotor axially between the port plates. If you mix up the shims from the drive end with the non-drive end, your rotor is going to sit off-center, and you will completely compromise those critical internal clearances we just obsessed over.
Let's move to Section 5 and see how this builds into our post-assembly checks and commissioning. Before you even consider hitting that motor start button, you have to run through these 3 non-negotiable checks. First, the manual rotation check. Turn the pump shaft by hand from the coupling side. It must turn freely and smoothly without any metallic rubbing sounds at all. This smooth rotation is your actual physical proof that your gasket thicknesses are right and your clearances are perfect. Second, perform a precise alignment check with a dial indicator to hit your parallel and angular tolerances. And 3, well, the pre-start water check.
Which brings us to our final, provocative point. You've successfully torn down the beast. You've painstakingly measured the internal clearances, torqued every bolt evenly, and perfectly aligned the shafts. But did you remember the seal water? Starting a water ring vacuum pump completely dry will instantaneously destroy all the internal components you literally just spent hours meticulously assembling. So always, always open that seal water line first and ensure service liquid is in the casing. Let that stark warning sit with you the next time you step up to the control panel. Thanks so much for learning with me today, and I'll catch you in the next explainer.